Welcome, Mr. Sutton here with the Pre-Cal Honors 9-1 Extra Practice number 3 solutions on finite intuitive limits. On this problem, using this graph of f of x, we want to find the following limits. So first one, part A, we have the limit as x approaches 0 from the left side. So taking a look here, we can't really approach the x value 0 from the left side at all because the graph doesn't exist there. So that one does not exist. Next, as we approach 0 from the right side, so right here approaching from the right side, we're approaching the y value 1. So that's the right-sided limit. The two-sided limit, depending on whether you allow one-sided limits to take the place of two-sided limits at endpoints, you could either say that this does not exist because it doesn't have two sides, or you could say that it equals 1 because that's what the one value actually does equal. So this is 1 or DNE. There's a little bit of debate there, but either of those would be considered acceptable answers. And then finally, f of 0, that's just going to be the y value there, which is also 1. So continuing our look at limits with this particular graph of f of x, we next have part E, limit as x approaches 1, and these are all dealing with 1. This is 1 from the left. So looking at the x value 1, as we approach from the left side, that's the y value 0. And then this is now the limit as we approach 1 from the right side. That's approaching right here. That's a y value of 1. Two-sided limit, since the left and the right-sided limits don't match up, the two-sided limit does not exist. And then finally, f of 1, that's the solid dot at x equals 1. That's up here. That's y equals 1. For this one, we're taking a look at the limit as x approaches 2 from pretty much every direction of this f graph here. So 2 from the left side, that limit as we approach 2 from the left, it looks like the y value 1. It also looks like as we approach from the right side, we're getting 1. The two-sided limit is therefore also going to be 1 since the left and the right-sided limits agree. And then f of 2, that's the solid dot at x equals 2. That's all the way up here. That's a value of 2. For this part of the problem, these four things, we're looking at the behavior as x equals 3. So the limit as x approaches 3 from the left side is the y value 2. Same thing as we approach from the right side, also going to be a limit of 2. That means the two-sided limit is also 2 because these two limits agree. And then f of 3, well, that's the solid dot at 3. Looking at the graph, there is no solid dot at 3. The graph does not actually exist at 3. So this one is going to be DNE. On this problem part, we're examining the behavior of the graph at x equals 4. So the left-sided limit at 4, as we approach from the left side, clearly we are heading toward the y value 1. Can't approach from the right side because there is no right side for the graph. This is an endpoint, so the right-sided limit definitely does not exist. The two-sided limit, you could either call that 1 or does not exist, depending on whether you believe you can have a two-sided limit at an endpoint. So there's definitely some debate about that one. F of 4 is definitely 1 because that's the value of the function at x equals 4. For this problem, we're taking a look at the h function and trying to find various limits and function values. So taking a look at part A, limit as x approaches 1 from the left side. So here's x equals 1. As we approach from the left side, we're heading toward the y value 2. So that's our left-sided limit. Part B, as we approach 1 from the right side. So as we approach from the right side here, we're approaching the y value negative 3. And this is talking about now as x approaches 1, this is the two-sided limit. Because we're approaching different things from the left and the right side, this one does not exist. Those don't match up, DNE for that one. Next, h of 1, that's the solid dot at x equals 1. That's this dot right here, so that's going to be negative 1. Next, h of negative 2, that's the value of the function at negative 2. Looking at the graph, here's x equals negative 2. At that value, the graph has a value of 4. And then the limit is also going to be 4, because as you approach from the left and the right at negative 2, you're also approaching what the function equals there. For this problem, we have the graph of f, and we're exploring the behavior of the graph around x equals 0. So part A, we're talking about the left-sided limit. So approaching 0 from the left side, like so, we're approaching the y value negative 2. And now for part B, this is the right-sided limit. So approaching 0 from the right side, we're approaching the y value 1. For the two-sided limit at 0, which is what part C is talking about, we notice that the left and the right don't match up. So that means that the two-sided limit at 0, the overall limit, does not exist. And then finally, f of 0, this is the solid dot at x equals 0. Looking at the graph, we have a solid dot on y equals 1, so that's going to be f of 0. For this problem, we've got this f graph here, and we're asking about the behavior near x equals 4 for this graph. So part A, as x approaches 4 from the left side, well, as we approach from the left, we're approaching the y value 2. Part B is talking about the right-sided limit. As you approach from the right side, we're also approaching the y value 2. Since these two limits are the same, that means the two-sided limit is going to match what the left and the right are, which is also 2. And then finally, f of 4, that's the actual value of the function at x equals 4. Looking at the graph, we've got an open dot there and no solid dots, so that does not exist.